So we're told that we have some function f with x-intercepts at -3, -1, and 1, and we want to find which of the following could define f. So let's just quickly go back to our graphic or graphical understanding of quadratics, right? When we have some quadratic, let's say f of x expressed as, two factors, like maybe x plus 2 and x plus 3. We remember that when we set this equal to 0, we find that the solutions are x would be -2 and x equals -3. We also understand that those values are the x-intercepts, right? Why is that? Well, again, think about it. When you're setting this thing equal to 0, you're saying, or you're looking for the x's when y is 0, right? Which is why it occurs when it crosses the x-axis, because that's precisely what where the point is when y is 0. So, basing our sort of intuition on this, we can pretty easily find the answer to this problem, because we know that if our x-intercepts are these things, so we know that x equals -3, x equals -1, and x equals 1. Again, I'm sort of working backwards. So if we know this, then we can say that the original factor was x plus 3 equals 0, right? The original thing here that you set equal to 0 was x plus 1 equal to 0, and the original thing here that you set equal to 0 was x minus 1. So these were all factors of this, whatever f is. So we can say that f could be x minus 1, x plus 1, x plus 3, like that, right? Because again, think about it. You're saying that these are all factors. So again, if any one of them is 0, then the entire thing goes to 0. And you're trying to find x-intercepts. What's the y value of x-intercepts? Y value is 0. So this would be 0, and you would solve this just like you would a quadratic, right? So all it is you're working a little bit backwards. Instead of being given the function and finding the x-intercepts, you're given the x-intercepts and sort of work a little bit backwards to find what f of x could be. So that is C.